Well, hello everybody. Hope everybody's doing great. Just let me know, email me or just connect with me somehow and tell me what you need and I'll help you out. Hey, today's pretty straightforward. It's going to be using the Pythagorean theorem and some averaging, and wow, we'll find out some cool stuff. So what are we doing? Well, there is a real live line segment right there for you, and all we're looking for is how would you find if you knew the coordinates of the two endpoints A and B, then how in the world would you find the coordinates of the midpoint? And then how would you find the distance? What is the distance? So two things, midpoint and distance. Hey, I like these warm-ups. So we're going to do one or two of these real quick. A slope, the slope, the slope, slippery slope. Let's get a little thinner. There we go. Hey, slope is rise over run. Okay, the difference of y's over the difference of x's. So y2 minus y1 over x2 minus x1. So the slope of this ladder from here to here is going to be a rise of 40 over a run of 20. And that reduces down to 10 goes into 4 over 2 or 2 over 1. Hey, what that means is it goes up 2 feet for every 1 foot it goes over. Up 2 feet for every 1 it goes over. So when we talk about rate of change, it's like 60 miles per hour. All right, those of you who drove to school or will drive to school at 60 miles per 1 hour, that's a slope. It means you're changing 60 miles for every 1 hour. Here you're going 2 feet up for every 1 foot horizontal. So slopes actually are really cool and they mean something outside of algebra class where you're finding like this is a classic example of why people hate slope because who cares? Nobody. But what we do care about is speeds. We talk about rates of change. We talk about COVID, the rate of which it is infecting. Those are all slopes that we're a little bit more interested in. So it gives us a little bit more credit to maybe actually these are kind of cool because they are trying to get you there. So don't dismiss them just because they're hard to connect to, but know that they're probably the most important. All calculus is based, or differential calculus is based on the slope of a line, believe it or not. So how would you find the slope? Well, count them. It looks like you go up 1 over 2. You're done. That's a slope. So on a graph, that's a really easy way to do it. No, Mr. Sayers, I always need to use the formula. Well, use the formula. So that's 1 minus 0. So I took that 1 minus that 0, and then I'll take that 4 minus that 2. I get 1 over 2. Same thing. Cool. All right. That's a little thing on slope. Find the missing angle. So when you have 3 angles in a triangle, we know the sum will be add up to 180 degrees. So if we took 180 and we subtracted 90, we get 90. And then we take 90 minus 28, and we get 62 degrees. In 4, when you have 4 sides, they all add up to 360. So we would take 360 minus these three, 101 plus 119 plus 71. Notice I put these all in parentheses. I'm going to add them all up, subtract them 360, and I'll get my x degree. Cool. Just for kicks and giggles, if you have 5, they add up to 540 degrees. So 180, add 180 to get to 4 sides, and add 180 again to get to 5 sides. Gee, I wonder what 6 sides is. We are not doing that. We are not doing that. All right. So here is the core concept. Yep, sorry. Sorry about that, jumped around a little bit. Hey, midpoint, use your common sense here. If we have A and B, the midpoint is that point right in the center. And I think what's so important about making sure that you understand this is understanding this notation right here and here. That means AM, that distance, no line on top, is equal to MB. Okay, so it's that symbol. It's understanding the notation. When you put those that tick mark, any segment with one tick mark will equal any other segment with that one tick mark. Okay, so that's just saying that those are equal. All right. Notice the notation once again. If we want to say line segment AM and line segment MB, then we use the congruent sign. So we're saying that shape is congruent or the same size as that shape. If we don't have the line over the top, then we're saying the distance, which is a number, is equal to that distance. All right. Hey, a segment bisector is anything that actually cuts the line or the segment in half. So here it's pretty easy to see that this green line cuts through right at M. So we call it a segment bisector because what is it doing? It's cutting that segment, it's bisecting it. So it's really the word bisector that we have to understand. So we have the word bi, which is two, okay, bicycle, two wheels. Intersect, that means, hey, boom, boom, beam, pop, boom, 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 they touch. So when we say bisector, we're saying that it touches or it intersects and cuts it exactly into two equal parts, two equal parts. So we say it bisects the segment. So when you hear the word bisector, yeah, I want you to think of a couple things. I want you to think about you're taking something, you're cutting it exactly into half, creating two equal parts. Because the word bisector is going to come up a lot in this class. All right, so we'd say the line CD bisects is a segment bisector of AB. We could say that M, just the point M, is the segment bisector. So that's another way to look at it. This is dumb. All right, identify the segment bisector. Well, the segment bisector here is the ray MN. So that's what's actually cutting it in half. How do I know it's cutting in half? Because it is written. Point M is the segment bisector because that's the object that is cutting it exactly in half. How do I know it's exactly in half? Because it's marked. So then we're supposed to find the whole thing, P to Q. Well, that's what they're asking for. Well, if that's 1 7/8, we know this is 1 7/8. And so to find PQ, we would add 1 7/8 plus 1 7/8. That's going to be, the 1 plus 1 is 2 plus 7/8 plus 7/8. I like to do that. I like to take the whole numbers and add those. So that's where, that's where that 2 comes from. And then I add the little partial fractions. Hey, they have a common denominator, all right? So that's 2 plus 14/8. And 8 goes into 14 at least once. So that's equal to 2 plus 1. And how many are left over? 6/8. So that's 3 6/8. Also known as 3 3/4. So you might get a little fraction work. That's kind of fun. Point M is the midpoint of VW. Find the length of VM. So what this means is, yep, they're equal. So that's telling you, take those expressions and do something with them. If they're equal, then use the power of algebra and set them equal. And that's because we have the definition of a midpoint. We can say, since it's a midpoint, we know one side equals the other. So that's how we prove in quarter law. So then we subtract 3x from both sides, add 1, And unfortunately, this is the best wrong answer because it is not finding the length of VM. It's finding what X is. Well, how do you find VM? Then you plug in to 4 times 4 minus 1, 16 minus 1, 15. Because VM, remember, is equal to 4X minus 1. All right? Identify the segment bisector of PQ, then find MQ. Well, it is the bisector because it's marked. Since it's marked, we can set these equal to each other. Boy, I wonder if you're going to do that a lot today. Yes, you are. So to get the x's on one side, I'm going to add 2x to both sides. Sometimes I'll write it out like this. Sometimes I'll just go faster. I'm going to add 3 to both sides. And I'm going to divide both sides by 7. Once again, best wrong answer. That's going to be the answer on the SAT and the ACT and all that good stuff. But they want to know what MQ is. They want to know what MQ. Well, MQ is equal to 11 minus 2x. Now we use that x, plug it in, and we get 11 minus 2 times 2, 11 minus 4, or we get 7. All right. Think you guys can handle that? All right, so how do you find the midpoint given coordinates? So let's say I have these 2 points. And I want to find the midpoint. First of all, common sense. The midpoint, is it here? Is it here? Is it here? Where's the point that is exactly in between those 2 points? You know what? I'd say right about there. Come on. At least know what you're after here, right? So there you go. That's our coordinates. That's what we're after. Well, visually, let's just take a look at this. There's the x coordinate of the first one. There's the x coordinate of the second one. And look at that. That's what we're after. We're looking for the x coordinate of the midpoint. Well, isn't that right in the middle? Right in the middle of those 2 x values? Well, if they're right in the middle, how do you find the average of 2 numbers? How do you find the middle of 2 numbers? Yes, I know you're thinking it. You're not sure of it yet. You're like, well, I think you just, if I gave you 2 quiz scores and asked for your average, you would add those up and you would divide by 2. That's the x coordinate of the midpoint. Come on, Sarah, really? That's it? That's it. So let's do the same thing with the y values. There's the y value of the first one. Here's the y value of the second one. And what are we after? We're after the y value of the midpoint. So, ladies and gentlemen, if I want to know the number right between those 2 values, then I just add them and divide by 2. So let's let it all sink in here. What do we have? We have, if these are the coordinates x1, y1, and these are the coordinates x2, y2. And don't let that subscript mess with you. It's just coordinates at any 2 points. So how will I find the coordinates? If I know these, then all I do is add, blah, 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 blah. I add those 2 together. That will give me my x coordinate, and I add the y coordinates, and that will give me my y coordinate. That's it. So here's out of the book. They give you this kind of a picture, and instead of me trying to walk you through the picture, I just developed the picture for you. So there it is in the book, and you can read that and feel good about it. Let's do some problems. The endpoints of RS are that and that. Find the coordinates of the midpoint. All right, so you can always graph it and find it graphically, but we're going to use our midpoint formula. x1 plus x2 over 2 and y1 plus y2 over 2. So take the x's, 1 plus 4 over 2, and we take the y's, negative 3 plus 2 over 2, and just work it out. That's going to be 5 over 2, and that's going to be negative 1 over 2. There you go. So if I graph that, that would be exactly in the middle of points R and S. All right. So you're like, hey, Mr. Stairs, I can add, I can divide by 2, I own this. But then they mess with you a little bit and they give you this problem. So just to give you a kind of a picture of what's happening, usually you're given the 2 endpoints and you're asked for the midpoint. So, but they're telling you the midpoint is 2, 1, and they're telling you that one of the endpoints is 1, 4, and they're asking you, what is this? Well, interesting. So remember how to find this? This is x1 plus x2 over 2, and this is y1 plus y2 over 2. Okay, so algebraically, we could say that x1 plus x2 over 2 is equal to 2, because we know it's equal to 2. Now, do we know one of the x coordinates? You bet, it's 1. So we'd say 1 plus x2 over 2 is equal to 2. I could multiply both sides by 2. That cancels that. So I get 1 plus x2 equals 4. Subtract 1. I get 3. So I know the coordinate here is 3. I can do the same thing with y values. y1 plus y2 over 2 is going to be equal to our y coordinate, 1. Multiply both sides by 2, and we get y1 plus y2 is equal to 2. Do we know any other y coordinates? You bet. There's that one. So I'd say that's 4 plus y2 is equal to 2. Subtract 4 from both sides, and we get negative 2. So I know that this point is 3, negative 2. Mr. Sayers, I think I have a better way. All right, Mr. Smarty Pants, let's see it. So I'm going to show you a way that somebody showed me last year in my class, because they are so smart. Same problem. So it helps to have kind of a better picture. So 2, 1, that's M. 1, 4, that's J. And we know that's 1, 4, and that's 2, 1. So if that's the midpoint, then our other point's somewhere right in here. Well, this and this is going to equal this and this. So if we went from 1 to 2, we added 1 here. If we went from 4 to 1, we subtracted 3 here. So if we subtract 3 down and move over 1, then we should get our new point. So if we move over 1, we add 1, we get 3. And if we start at 1 and we go down 3, then we do that. I think people like the visual of that. Extra examples. So you can fast forward through this. I'm going to just do one more example of each. The endpoints. So I'm going to do 1 plus 7 over 2. And I'm going to do 2 plus 8 over 2. And that's 8 over 2 and 10 over 2, which is equal to 4, 5. There's your midpoint there. And I'll do number 7 here, the midpoint of TU. So we know the midpoint is 2, 4. 2, 4. One endpoint is 1, 1. So we're looking for this right there. All right. So what did we do to get there? started at 1 and we got to 2, so we moved plus 1 in that direction. And we started at 1 and went to 4, so we went up 3 in that position. So if we take our 2, our point 24, and we go plus 1 in the x and plus 3 in the y, we're going to get 3, 7. So the midpoint, finding the endpoint, if you're given the midpoint and the endpoint, is kind of nice. Just look at the pattern. Look at the pattern. All right. A, B, C. This is called the Pythagorean theorem. A squared plus B squared equals C squared. So the distance A squared plus the distance B squared is equal to the distance C squared. All right, so we're interested in knowing the distance between 2 points. All right, so our goal is to find that distance. Okay, well, we kind of use the same idea. If this is x1 and this is x2, then that's a distance that we can figure out. If we know the coordinates of that point and the coordinates of that point, we can figure out that. And that is going to be x2 minus x1, the difference between those x values. Remember, if like this was 2 and this is 8, 8 minus 2 is 6, so we'd say the difference is 6 right there. Okay, and then the y values, y1 and y2, the difference or the distance here is going to be y2 minus y1. So if this was 1 and this was 8, then 8 minus 1 is 7. So we know the distance between here and here is 7. And that gives us that length. So this is going to be x2 minus x1, and this is y2 minus y1, and this is the distance. Ladies and gentlemen, the Pythagorean theorem, a squared plus b squared equals c squared, is alive and well. So what we say here is x2 minus x1, the difference between the x's squared, plus the difference of the y's squared, is equal to this length squared. That is the distance formula. I love it. But Mr. Sayers, you're trying to find the distance, not the distance squared. So we'll take the square root of both sides, and we will get our newfound formula. I'll just start with what we had. If we decide to take the square root of both sides, that undoes the square. The square root of a perfect square is just the square. So we get d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Circle star that, take that to the bank. There it is. If you want, they use AB, I use D for distance. Either way works. Let's skip that one. Skip that one. All right. Good question here. If you have 2 points, can you find the midpoint and can you find the length? All right. So this is our first example of length. So we'll find that first. Would you please make sure you write down the equation to start, especially the very beginning, so you kind of remind yourself what you're doing. You just plug stuff in now. Remember, these are the x's and those are the y's. So these are the x's and these are the y's. So if we go 4 minus a negative 3, look how I'm using my parentheses. I'm really careful. So I did the x's and then the y's, negative 1 minus 5. Order doesn't really matter, believe it or not, because you're either going to get a positive or negative, but when you square anything, you get a positive. So it's kind of cool. Let's just do this one at a time. A minus is a plus. Minus 1 minus 5, since they're both negative, you just kind of combine them. So you're down $1, you go down $5 more, you're down $6. And then keep going. This is 7 squared plus negative 6 squared. Notice I'm using that parenthesis right there just to keep myself honest. 49. Negative 6 times negative 6 is positive 36. And we get the square root of 85. Hey, leave your answer in exact form like that. Square root of 85 is better than 9.3712, whatever. So you can leave your answer like that. All right, so that's it. Uh, let's do this one. This is your ticket that says that you did this. I would like you to find the length between 1, 3, and 4, 7. Okay, find the distance. Give it a shot. All right. Let's say you did it. Let's just check your work. So the distance is equal to the square root of the difference of x's plus the difference of y's. And that's equal to the square root of 4 minus 1 squared plus 7 minus 3 squared. 3 squared plus 4 squared is equal to 9 plus 16 equal to the square root of 25, which is equal to 5. Hopefully that worked out for you. Peace out.